Hello, I'm Dr. Dalia Tsimpida, and I'm a postdoctoral researcher in the Institute for Health Policy and Organization at the University of Manchester, UK. It's a pleasure to participate in the virtual conference on computational audiology. I'm presenting today the topic, Prevalence Statistics of Hearing Loss in Adults, Harnessing Spatial Big Data to Estimate Patterns and Trends. I'm going to cover two main topics. How big is the problem of hearing loss in England, and the power of big data in estimating patterns. Hearing loss is a major public health issue, estimated to affect over 9 million people in England, which translates to 1 in 6 people. I've just said 9 million. There is no screening program. So how is that being calculated? To date, the prevalence estimates of hearing loss in England are calculated using data from a study by Davis, who collected and analyzed audiological data in the 1980s. Despite its importance to the history of hearing care in the UK, Davis' study had some significant limitations. First, the prevalence estimates are based on a sample of only 2,578 participants. According to the hearing problems of that sample, a percentage of hearing loss was calculated for each age group that participated in the study. For example, 18.9% of those 51 to 60 years old had hearing loss of over 25 decibel hearing level. Today, each clinical commissioning group, who is responsible for an area in the UK, uses the population demographics to estimate the number of people with hearing loss in their area. For example, the population demographics show that in 2015, in central Manchester, there were 40,000 people aged 51 to 60 years old. Therefore, according to the percentage of the Davis study, it is estimated that 2,720 of them may have hearing loss. However, this audiological data was collected and analyzed in the 1980s, and this data's accuracy has not been validated in the last 40 years. But importantly, calculating the local hearing health needs through this audiological data, we assume that the percentage of those with hearing loss will remain the same no matter the place that people of the same age live. However, this does not reflect the reality, because where people live plays an important role in their health, as the location shapes several environmental risks. In Davis' study, the English samples were derived from only two cities, Nottingham and Southampton, so the samples are very unlikely to be representative of the whole population of England. In other words, that study did not consider in its estimation the effects of place and socioeconomic factors such as high occupational noise exposure from manual occupations and differences in regions of England with strong and weak manufacturing industries. Where people live significantly affects their hearing outcomes. If it didn't, and only age was responsible for the loss of hearing as we grow, we would expect that the prevalence of hearing loss in people of the same age would be the same no matter where they live. In order to test that assumption, I analyzed all the available hearing data in the English Longitudinal Study of Aging, or ELSA. Due to the sampling method, the participants in ELSA have similar mean age profiles over time, as the study is a representative study of the English older population aged 50 years old and above. The number of people with a hearing loss increased by 10% 5% over 15 years. However, the mean age of the people I analyzed stayed the same. You can easily look at the different colors that represent the differences in hearing loss prevalence derived from people that have similar age profiles in each region and in each year of collection. Over the same period, the samples had markedly different hearing outcomes in terms of where respondents lived, and the increased rate of hearing loss ranged from 3.2% to 45% in between regions of England. Remember that these representative samples were from people with similar age profiles. The results provided surprising evidence that the increasing trend in hearing loss prevalence was not age-related as widely believed, but is potentially due to social and lifestyle changes. This is a significant milestone in hearing research and a breakthrough that gives us considerable insight into what is actually happening. A natural next step was the PLACE project that I currently run as the primary investigator. This project provides a significant opportunity to validate the existing audiological data after nearly 40 years. The study utilized data from the seventh wave of the English longitudinal study of aging, which contains objective hearing data for 8,529 participants aged 50 to 89 years old that gave consent to have their hearing acuity measured by a handheld audiometric screening device. The objectively identified hearing loss was defined as greater than 35 decibel hearing level at 3 kHz in the better hearing ear. Aims were to explore regional patterns and identify potential regional differences in the current prevalence estimates of hearing loss in England. The estimates of hearing acuity in regions of England for 2015 are shown in the slide. The four panels on the top show the estimates according to Hearing in Adults study by Davis, who estimated the prevalence of hearing loss for the four age groups respectively. You can see that the percentage of those with hearing loss remains the same, no matter the place that the people of the same age live. The four panels on the bottom of the figure show the estimates according to the English longitudinal study of aging. We can see that the hearing loss estimates are currently vastly underestimated in most regions of England, particularly for the age groups 51 to 60, 61 to 70, and 71 to 80 years old. The findings show clearly that the hearing loss prevalence is not related to the aging of the population as traditionally believed, but potentially to social and lifestyle changes and population differences across different regions in England. These findings have important implications for health policy and planning for health services in England and globally that should be based on the actual needs of the populations and not on the age of the populations through projections. Now I will explain why a socio-spatial approach is crucial for planning sustainable models of hearing care. The unequal distribution of power, money, and resources in society leads to social inequalities. As a result, some groups of people are more privileged than others, which creates injustice and disadvantage that influences life experiences and health outcomes. I and my colleagues have proposed a novel theoretical framework that examines the mechanisms and explains the relationship between socioeconomic inequalities and hearing health over a lifetime. According to this model, hearing deterioration is a lifelong process and not an inevitable result of aging. Understanding this process is an essential step in addressing the global burden of hearing loss. The PLAY study is the first that used big data to investigate on basis of geographical patterns of objectively identified hearing loss in a nationally representative sample of older adults and not only on age demographics. Future research that will generate epidemiological hearing data using large datasets is crucially needed to understand better the impact of socioeconomic inequalities and the personal characteristics on hearing loss outcomes during the life course in order to improve diagnostic procedures, harnessing what computational audiology has to offer. The topics of my presentation today were the figures of hearing loss in England, findings of the PLACE project, the power of big data in estimating patterns of hearing loss, and why do socioeconomic position and lifestyle matters. I'm sure you will now have realized that applying computational audiology approaches might offer promising solutions to generate large-scale epidemiological inferences to improve populations' hearing health. Thank you very much for watching my presentation.